In this example, we have a 100 microcoulomb charge is placed at the origin. A 300 microcoulomb charge is placed 1 meter above the origin, and a negative 200 microcoulomb charge is placed 2 meters to the right on the origin. What is the magnitude and direction of the net force acting on the charge placed at the origin? So I can say the first one is positive right here. I'm gonna call it Q1. That's plus 100 microcoulomb. And a positive 300 microcoulomb is here. I'm gonna call it Q2. The distance is 1 meter. And it says a negative 200 microcoulomb charge is placed 2 meters to the right. So let's say negative Q3, negative 200 microcoulomb. The distance is 2 meters. What is the magnitude and direction of the net force acting on the charge placed on the origin, which is this one? So first of all, we have these two are like charges, so they repel each other. So F12 is going to be on this direction, and these two, the force on Q1 due to the presence of Q3 is going to be in this direction because they attract each other because of unlike charges. So F31 I call it. I'm gonna find out the magnitude of these two. F12 is K using Coulomb's law times K1 Q2 divided by R squared. K is 8.99 times 10 to the power of 9 times Q1 is 100 times, I need to convert it to Coulomb. Since it's microcoulomb, when I convert it to Coulomb, I need to multiply it by 10 to the power of negative 6. Q2 is 300, so it's going to be 300 times 10 to the power of negative 6 divided by R squared, that's 1, it's going to be 1 squared. The answer will be 69.7 Newton. F31 now is going to be K times Q1 times Q3 divided by R squared. That's going to be 8.99 times 10 to the power of 9. Q1 is 100. 3 is 200. And R is 2 meters, so 2 squared. That's negative 6 times 200 times 10 to the power of negative 6 divided by 4. That's 44.95 Newton. So now the force F31 we have, F12 we have. We need to find F net. F net will be F12 squared plus F31 squared. It's going to be 44.95 to the power of 2. It doesn't matter which one you write first. 44.9 to the power of 4. 269 to the 2. Then you find the square root of it. It's going to be 273.42 Newton. And then, how to find the theta, because this one is going to be F net. How to find this theta in here, we can say opposite is going to be F12, adjacent is going to be F31. So I'm going to say tan theta equals to F12 divided by adjacent, which is F31. It depends on which side you take. If you choose here as theta, in that case it's going to be F31, which is the opposite, divided by adjacent, which is F12. But I define theta as the distance between the angle between this line and this line. So F12 is 269.7, F31 is 44.95. That's going to be 6. So theta will be tan inverse of 6. It's going to give me 80.5 degrees. Let's say 81 degrees if we round it. So this side is going to be 81 degrees. This side is going to be 9 degrees.